this video, we're going to make a saturated sodium chloride solution and see if the chloride as a common ion will have any impact on the solubility of the sodium chloride. So let's get started. For the experiment, we're going to use some sodium chloride or table salt. We are going to use a concentrated hydrochloric acid solution, which we will pour right before use into a small beaker. And we will use some deionized water. For equipment, we're going to need a scale. We will measure our sodium chloride directly into a beaker because we will be measuring 18 grams. We will need a relatively large 50 or 100 milliliter graduated cylinder. And to add the hydrochloric acid, dropwise, we're going to use a pipette with a bulb. Let's get started. First, we're going to weigh out inside our beaker 18 grams of sodium chloride. So we turn on the scale, place our beaker on top, tare it, and then pour into the beaker 18 grams of salt. I have exactly 18.00 grams of salt. And with that, I am done with the scale and I can set it aside. Next, I'm going to take my graduated cylinder and measure 50 milliliters of water. I have 50.9 milliliters. I will pour this on top of my salt. And with that, I am done with the water. Next, we need to convince the salt to dissolve in the water. And it will probably take a couple minutes because this is as much salt as we can dissolve in this amount of water. Our sodium chloride dissolved in the small amount of water that we added, so we have a saturated sodium chloride solution. If, however, your ratio of sodium chloride and water is not quite matching the solubility limit of sodium chloride, then if you have sodium chloride still floating in your solution, you can always do a quick filtration and the resulting solution will be a saturated sodium chloride solution. At that point, you are where I am in this experiment. You can take your concentrated hydrochloric acid and pour a very, very small amount of it into a beaker. Then you will take a pipette, extract just a couple drops, and then you will add your hydrochloric acid into your sodium chloride solution. The additional chloride ions that are added should cause the sodium chloride to precipitate from this solution. And so you can see the formation of sodium chloride, but you see it in very, very small particles and not the grains of salt that we're familiar with. This addition is sufficient to observe the impact of the chloride as the common ion effect on the solubility of sodium chloride in water.